Welcome to the lecture on system architectures, and after the lecture we will be able to learn the following objectives. Understand the TCP/IP naming and addressing, explain the locators and names, define TCP/IP applications and application services, discuss TCP/IP protocol in details, understand about gateways. Let's start with a brief introduction to system architectures. The term system architecture is used to describe the overall design and structure of a computer network or system. There are some main components to any system architecture: processing power, storage, connectivity, and user experience. Processing power is based on the computer or server. This hardware is akin to the brain of the system. Storage space is based on the number and capacity of the hard drives and related devices built into the system. Managing network traffic and connectivity is an important part of the system design. Upgrading network cable switches, routers, and other equipment is expensive and time-consuming, but has a huge impact on system performance. The user experience is based on a combination of system architecture and performance. Business clients typically have minimal understanding or interest in all the aspects of the system that can positively or negatively impact his or her individual computer. As well-designed support system is responsive to users' needs and can support the operation in the long run. Servers commonly contain data files and applications that can be accessed across the network by workstations or employee computers. An employee who wants to access company-wide data files, for instance, would use his or her client computer to access the data files on the server. This type of server is called an application server.
The most basic division of a computer system is between the hardware and the software. Hardware is often described as the physical parts of a computer that you can actually touch with your hands, although that is not recommended, especially when the power is on. Software includes all the programmed instructions in a computer. There is the main program called the system software, also known as the operating system, which controls and interacts with the hardware and software components. Application software are programs like Photoshop, Internet Explorer, and World of Warcraft. The main hardware components include the CPU, or Central Processing Unit, main memory, secondary storage devices, and the input and output devices. The CPU is a microchip that receives and decodes instructions from memory. Within the CPU are specialized units. One is the arithmetic logic unit. This part performs operations with numbers. The control unit manages the flow of instructions in time with the CPU clock. The faster the CPU clock, the more instructions that can be processed at a time. The processor I have is a quad-core. That means that there are 4 copies of the same transistor circuitry within one chip. With 4 cores, my processor can execute 4 times as many instructions at a time than if it only had 1 core. The main memory is volatile. That means whatever data is held here would be lost if the power went off. Volatile memory needs a constant flow of electricity to work, so it's only used for instructions in active use. Otherwise, data is stored in a permanent storage device like the hard drive. The main memory can be imagined as a sequence of cells that are either empty or contain instructions or data. Each cell has its own unique address. In the actual hardware, electrical signals of on and off represent all computer information. These on and off signals are called bits. The hardware of a computer is like a kitchen. It includes all the equipment necessary for cooking food, as well as an energy source and location for performing the processes of cooking. The kitchen is where the ideas of a recipe are translated into edible meals. A recipe is like software. A recipe is just a series of written instructions that tell you how to turn raw ingredients into a culinary masterpiece. By itself, a recipe is a useless piece of writing, but as soon as the recipe is interpreted and executed, the recipe has value as a functional tool that can be used again and again to produce the same result. Software is reusable. The instructions of software control the flow of data.
Let's now take a look at TCP/IP naming and addressing. The TCP/IP protocol suite is the most widely used in networking today. The TCP/IP has become sufficiently popular that many people, even non-geeks, are fairly comfortable working with its numeric identifiers, IP addresses. In the late 1960s and early 1970s, when the predecessor of the Internet was being developed, it used older networking protocols that served the same function that TCP and IP do today. The ARPANET was very small by today's standard, containing at first only a few machines called hosts, just as TCP/IP machines often are today. The first ARPANET name system, host name lists. Naturally, the ARPANET engineers immediately recognized the dangers of having each site maintain a list of possibly inconsistent host names. Since the Internet work was just a small club at this point, they used the request for comments RFC process itself to document standard host name to address mappings. This initial name system was about as manual as a system could be, storing host names in a host table file. The first improvement was to make the list of host name assignments a standard master text file that would be centrally managed and could be downloaded using network protocols like FTP. The file was maintained at the Network Information Center, NIC, at Stanford University. These documents also formally specified the syntax for the TCP/IP host table name system. Outgrowing the host table name system and the transition to DNS. It was around this same time that continued growth of the ARPANET Internet made apparent that the simple host table name system would eventually become unmanageable. With at first dozens and then soon hundreds and thousands of new hosts connecting to the internetwork, a single text file maintained in a central location just was not up to the task for a variety of reasons. Let's now have a look at Uniform Resource Identifiers, URIs. The term URI, developed after URL, had already gained widespread public use, hence URI is used by those involved in Internet development, standards, and protocols, while URL is the prevalent term outside those circles. The URI is characterized as uniform. Uniformity provides several benefits. It allows different types of resource identifiers to be used in the same context, even when the mechanisms used to access those resources may differ. It allows uniform semantic interpretation of common syntactic conventions across different types of resource identifiers. Resource. This specification does not limit the scope of what might be a resource. Rather, the term resource is used in a general sense for whatever might be identified by a URI. Familiar examples include an electronic document, an image, a source of information with a consistent purpose, a service. Example, an HTTP to SMS gateway, and a collection of other resources. Identifier. The use of the terms identify and identifying refer to this purpose of distinguishing one resource from all other resources, regardless of how that purpose is accomplished. Example, by name, address, or context. URIs have a global scope and are interpreted consistently regardless of context, though the result of that interpretation may be in relation to the end user's context. A web browser is software used to cruise the World Wide Web. Every browser has a URL window where the address of the currently viewed web page is displayed. Clicking on a hyperlink within a web page will direct the browser to a new URL or web address, changing the text inside the URL window. A URL can be composed of words such as abcd.com or the corresponding Internet Protocol IP address 69.93.118.236. Either address will take the surfer to the ABCD site. The vast majority of surfing is done by entering the name of the website, as names are easier to remember than numbers. It is a good idea to be at least marginally familiar with what a website address looks like. Common web pages start with http:// for Hypertext Transfer Protocol. Pages that start with http:// are not encrypted, so all information that passes between the computer and the internet can be seen by eavesdroppers. For this reason, it is unwise to enter personal information into a web page that starts with http:// in the URL window. Let's understand about locators and names. Naming and locating. Example, library resources are both complex activities which have different aims. A URI can be further classified as a locator, a name, or both. The term Uniform Resource Locator, URL, refers to the subset of URIs that, in addition to identifying a resource, provides a means of locating the resource by describing its primary access mechanism. Example, its network location. The term Uniform Resource Name, URN, has been used historically to refer to both URIs under the EARN scheme, which are required to remain globally unique and persistent even when the resource ceases to exist or becomes unavailable, and to any other URI with the properties of a name. Let's now take a look on the Uniform Resource Locators, URLs, and Uniform Resource Names, EARNs. A Uniform Resource Locator, also known by the acronym URL, is a means of specifying the location and access method of an object on the Internet. It includes a scheme or protocol name that describes how to access the object. A Uniform Resource Locator consists of two parts. First is the name of a URI scheme, followed by a colon. A scheme defines the protocol or other method used to access the resource. The Internet Assigned Numbers Authority, IANA, manages a lengthy list of registered URI schemes. Hypertext Transport Protocol, HTTP, Secure HTTP, HTTPS, and File Transport Protocol, FTP, are probably the most common. The second part of a Uniform Resource Locator is scheme-specific and may include several components. This part of an HTTP URL often begins with www. Followed by a domain name. A numeric Internet Protocol IP address may be used in place of the domain name. The name can be followed by the path to a specific object. An EARN, Uniform Resource Name, is an Internet resource with a name that, unlike URL, has persistent significance. That is, the owner of the urn can expect that someone else or a program will always be able to find the resource. A frequent problem in using the web is that web content is sometimes moved to a new site or a new page on the same site. Both urn and URL are types of a concept called the Uniform Resource Identifier, URI. A urn is associated with another concept called Uniform Resource Characteristics, URC, which allows descriptive information to be associated with a urn, such as author, date, length, and so forth. Let's now get to know about TCP/IP applications and application services. The TCP/IP stands for Transmission Control Protocol, Internet Protocol. It is a set of network protocols that enable the computers over a network to communicate with each other. TCP/IP is a protocol suite which is named after the pair of its most important protocols, TCP and IP. The Internet Protocol Suite, commonly known as TCP/IP, is composed of a set of layers, wherein each layer is responsible for a particular network task and provides the upper layer with certain services. The lower layer protocols translate data into forms that can be physically transmitted over a network. The upper layer protocols deal with abstract data and function at a level closer to the user. The TCP/IP model consists of the link layer, the internet layer, the transport layer, and the application layer. Each layer consists of a set of protocols that function on the level of that layer. The link layer protocols are responsible for connecting the nodes in a network. The internet layer consists of protocols, specifications, and methods that are used to transport data packets across the network. The transport layer protocols deal with the transmission of data packets between source and destination network hosts. The TCP/IP protocol suite is the foundation of modem internet working and, for this reason, has been used as the primary platform for the development and implementation of networking applications. Over the last few decades, as the global TCP/IP internet has grown, hundreds of
connection used when they communicate.
Windows Sockets Interface. The Windows Sockets API is a standard API under Windows 2000 for applications that use TCP and UDP. TCP/IP utilities and the SNMP service are examples of applications written to the Windows Sockets interface. NetBIOS Datagrams. The NetBIOS Datagrams service provides delivery of datagrams that are connectionless, non-sequenced, and unreliable. Datagrams can be directed to a specific NetBIOS name or broadcast to a group of names. Delivery is unreliable in that only the users who are logged on to the network receive the message. The Datagram service can initiate and receive both broadcast and directed messages. NetBIOS Sessions. The NetBIOS Sessions service provides delivery of NetBIOS messages that are connection-oriented, sequenced, and reliable. A NetBIOS session uses TCP connections and provides session establishment, keep alive, and termination. Here we will discuss about TCP/IP protocol details. The TCP/IP, Transmission Control Protocol, Internet Protocol, is the basic communication language or protocol of the Internet. It can also be used as a communications protocol in a private network, either an intranet or extranet. TCP/IP is a two-layer program. The higher layer, Transmission Control Protocol, manages the assembling of a message or file into smaller packets that are transmitted over the internet and received by a TCP layer that reassembles the packets into the original message. The lower layer, Internet Protocol, handles the address part of each packet so that it gets to the right destination. Each gateway computer on the network checks this address to see where to forward the message. TCP/IP uses the client-server model of communication in which a computer user, a client, requests and is provided a service such as sending a web page by another computer, a server, in the network. TCP/IP communication is primarily point-to-point, meaning each communication is from one point or host computer in the network to another point or host computer. Protocols related to TCP/IP include the User Datagram Protocol, UDP, which is used instead of TCP for special purposes. Other protocols are used by network host computers for exchanging router information. These include the Internet Control Message Protocol, ICMP, the Interior Gateway Protocol, IGP, the Exterior Gateway Protocol, EGP, and the Border Gateway Protocol, BGP. The two layers of TCP/IP are defined by the separate spelled-out versions. Transmission Control Protocol is the top layer, the one that converts messages or files into data packets that are transmitted over the network connection to the destination computer and then reassembled into messages or files that can be read by the destination user. The lower layer of TCP/IP, Internet Protocol, provides the transmitting operation, configuring the connection's address so that the information gets to the right place. Let's now take a look at relays and repeaters. A network repeater is a device used to expand the boundaries of a wired or wireless local area network, LAN. Repeaters are simple devices that work at the physical layer of the OSI. They regenerate signals. Active hubs do that too. There is an important rule to obey while using repeaters, hubs, to extend a local network and is called the 5-4-3 rule or the IEEE way. The rule forces that in a single collision domain there should not be more than 5 segments, 4 repeaters, between any two hosts in the network, and only 3 of the segments can be populated. A WLAN repeater will pick up the signal from a wireless router and amplify it, propagating signal strength to boost the distance and coverage of the WLAN. A repeater connects 2 segments of the network cable. It retimes and regenerates the signals to proper amplitudes and sends them to the other segments. When talking about Ethernet topology, one is probably talking about using a hub as a repeater. Repeaters require a small amount of time to regenerate the signal. This can cause a propagation delay, which can affect network communication when there are several repeaters in a row. Let's now have a look at bridges and routers. A bridge reads the outermost segment of data on the data packet to tell where the message is going. It reduces the traffic on other network segments since it does not send all packets. Bridges can be programmed to reject packets from particular networks. Bridging occurs at the data link layer of the OSI model, which means the bridge cannot read IP addresses, but only the outermost hardware address of the packet. The bridge can read the Ethernet data, which gives the hardware address of the destination address, not the IP address. A router is used to route data packets between 2 networks. It reads the information in each packet to tell where it is going. Routing occurs at the network layer of the OSI model. They can connect networks with different architectures such as token ring and Ethernet. Although they can transform information at the data link level, routers cannot transform information from one data format, such as TCP/IP, to another, such as IPX/SPX. Wireless router. A wireless router can direct local traffic on a network. A modem is required if internet access is desired. In many cases, digital subscriber line (DSL) and cable internet service providers (ISPs) provide a pre-configured modem to connect to the service. This type of router can be connected to the modem to provide internet access to the network. There are several broadcasting standards, and a wireless router will support one or more, but not all of these standards. Wireless network specifications are set by the Institute of Electrical and Electronics Engineers, IEEE, and are known as the 802.11 standards. Let's get to know about the gateways. A gateway can translate information between different network data formats or network architectures. It can translate TCP/IP to AppleTalk, so computers supporting TCP/IP can communicate with Apple brand computers. Gateways will start at the lower level and strip information until it gets to the required level and repackage the information and work its way back toward the hardware layer of the OSI model. Gateways are very intelligent devices, or else can be a computer running the appropriate software to connect and translate data between networks with different protocols or architecture, so their work is much more complex than a normal router. For instance, allowing communication between TCP/IP clients and IPX/SPX or AppleTalk. Let's now have a look at hubs. In general, a hub is the central part of a wheel where the spokes come together. The term is familiar to frequent flyers who travel through airport hubs to make connection flights from one point to another. In data communications, a hub is a place of convergence where data arrives from one or more directions and is forwarded out in one or more other directions. A hub usually includes a switch of some kind. Let's understand about switches. Switches operate at the data link layer, layer 2, and sometimes the network layer, layer 3, of the OSI reference model, and therefore support any packet protocol. LANs that use switches to join segments are called switched LANs or switched Ethernet LANs. Switches, on the other hand, are more advanced. Instead of broadcasting the frames everywhere, a switch actually checks for the destination MAC address and forwards it to the relevant port to reach that computer only. This way, switches reduce traffic and divide the collision domain into segments. This is very sufficient for busy LANs, and it also protects frames from being sniffed by other computers sharing the same segment. Switches have built-in hardware chips solely designed to perform switching capabilities. Therefore, they are fast and come with many ports. Sometimes they are referred to as intelligent bridges or multi-port bridges. Let's now take a look at network management and SNMP. A network management system, NMS, is a set of hardware and or software tools that allows an IT professional to supervise the individual components of a network within a larger network management framework. Network management refers to the broad subject of managing computer networks. There exists a wide variety of software and hardware products that help network system administrators manage a network. Network management covers a wide area, including security, ensuring that the network is protected from unauthorized users; performance, eliminating bottlenecks in the network; reliability, making sure the network is available to users and responding to hardware and software malfunctions; automating network management. Use SNMP management software to monitor any network device on which one installs SNMP agent software. The SNMP agent, which is an optional component of Windows Server 2003, interacts with third-party SNMP management software to enable the sharing of network status information between monitored devices and applications and the SNMP management system that monitors them. SNMP background, developed in 1988 to provide network device monitoring capability for TCP IP-based networks. SNMP was approved as an Internet standard in 1990 by the Internet Architecture Board, IAB, and has been in wide use since that time. More recently, Internet Work Packet Exchange, IPX, based networks have added support for SNMP. Currently, most network equipment vendors provide SNMP support in their products. SNMP provides a method of managing network hosts such as workstation or server computers, routers, bridges, and hubs from a centrally located computer running network management software. SNMP performs management services by using a distributed architecture of management systems and agents. Now, in the end, let us summarize what we have learned in this lecture. The term system architecture is used to describe the overall design and structure of a computer network or system. An employee who wants to access company-wide data files, for instance, would use his or her client computer to access the data files on the server. TCP/IP has become sufficiently popular that many people, even non-geeks, are fairly comfortable working with its numeric identifiers, IP addresses. An identifier embodies the information required to distinguish what is being identified from all other things within its scope of identification. A uniform resource locator, also known by the acronym URL or URL, is a means of specifying the location and access method of an object on the Internet.